That makes more sense as to why you're looking at me like I have a leg growing out of my head or something. Okay, now you can see what's going on. Right. Okay. So the k should be easy to notice. What's the value for a? Or, okay, oh boy. Okay, we'll make a decision as to which one we want it to be in a second. And then the value for b, we need to know the period, right? So what's the period here? So this looks like negative 2 pi, and this looks like positive 2 pi. So I think the period is 4 pi, which tells us b then is 2 or negative 2, right? Okay. And our value for h should be 0. Good. Again, since we're using sine, we're taking 0, 0 and mapping it to the midline point 0, 0, which means that there's no left or right or up or down transformation going on, right? So this is our midline point from the parent function, and this is our midline point from the transformation that we're looking at. And since nothing happened, then there's no h. So last thing we have to do is decide about our a. Remember, we always usually pick b to be positive. You can always find an answer where b is negative, but it just makes life a little bit more difficult to deal with it that way. So I always just pick b to be positive because there's always an answer where b is positive, and I think it's just easier to find them. So the question becomes whether a should be positive or negative here. Here's the way that we'll think about it. So when I think about the parent function for sine, it looks like this. So it goes minimum, midline point, to a maximum, right? Our graph over here, though, goes from max to midline point to minimum. Notice that's the opposite order. So that tells me that the a should be negative. When you're using a sine function, you have to be careful about that. If we did a cosine function, it's a lot more obvious to tell when the a is positive or negative. So if we use the maximum, our parent function maps to a maximum, the a needs to be positive. If we had picked our parent function mapping to a minimum, the a would need to be negative. So cosine, it's much easier to see just right away when you find your h whether you have a positive or negative a, because you need to figure that out right away. With the sine, you have to look at the order in which the maximum and minimums are coming in respect to that midline point. Does that feel okay there? Yeah. Okay. Dan? Sure. Before we change course, are we good with 7, Ben? B, I'm always going to pick to be positive. You can find an answer where b is negative, but I don't know if it's much harder, but I don't think it's as intuitive, because I think to me, figuring out the reflection up and down is easier than determining a reflection left or right. Now for this problem, it's not so bad, because if we pick b to be negative, then the a has to be positive, and it's really kind of the same thing. But because the b also affects the h, if the h was not 0, then it becomes a little bit, you have to worry about the sign on the h also, and it just gets a little bit messier. So I usually always pick the b to be positive, because the positive doesn't affect anything else. Right. Yes. Okay. And Dan, you wanted worksheet 2 number, what number? Worksheet 3, number 4. I was all wrong. Okay. Worksheet 3, number 4. So, a couple of things straight away. So it says to use a cosine function. So the first thing I would do is figure out the midline point. Which we can eyeball right there. So the midline is y equals -1, which tells me my k is -1. Everybody good with that? The amplitude is the distance from any extrema back to the midline. So here that amplitude is 3, which tells us that a is 3 or -3. We good with that? Our period is going to be just like extrema to extrema. So this is 3 pi over 4. And this would be like, what's that, 7 pi over 4? Right, if that's a half and 1, that's like 3/4. If that's 1 1/2 and 2, that's 1 3/4. Everybody agree with that? So that distance then is just pi. That tells us that the b is 1/2 or -1/2. Is everybody okay there? Okay. So last thing we have to do is figure out h. So I'm going to use either the maximum or the minimum, because I know for cosine, the parent function starts at 0, 1 as the maximum. So in my transform function, which point do you want to use? It doesn't really matter, but it changes our answer depending on which we pick. Okay. So let's pick that one. And we observe that that's also a maximum there, right? So since we're going max to max, that fixes the a value. The b, we always know we're going to choose to be positive. And our h then just becomes that x coordinate.
Like I got that, and I got the sine function.
Okay. So they should be the exact same thing. So we'll type in this one. So this was y equals, what was it, 3 cosine 2. And then it was x minus pi over 4 minus 1, right? And graph paper, let's make that the trig axis. And let's get rid of all those grid lines. Okay, so that looks identical to the picture there, right? If I pull them up at the same time. We agree, though, that that's the same picture? Okay. Oh, yeah, that would do it. So what Dan is saying is he forgot this inner set of parentheses here. You could eliminate those if you wanted to distribute this through, but you have to make sure you distribute to the fraction also. And you can do that, and it should give you the same picture. Cool. Good questions, guys. Who else? Josh? For this problem we just were talking about? Okay. So one period is like, there's lots of ways you can think about it, but it's basically just one cycle. So if I go from like minimum to minimum or maximum to maximum, or like, get a section where I have, a midline point, then a maximum, then a minimum, then another midline point, like any of those is a way to think about one cycle. So I just picked this section here that goes from minimum to minimum. Yeah, so I just went up and figured out, okay, so that's 3 pi over 4. And that's 7 pi over 4. So the amount of distance I traveled there was 1 pi. And that was my period. Does that feel okay? Again, there's lots of different ways you could have scoped that period out. I just, that one felt easy enough to me. The period? You could have like 1.5 pi's or something be your period, sure. 0.375? I mean, I probably wouldn't be able to cook something up that I would expect you to be able to come up with, like that's, first of all, like that's a big wide wave. So it's like going to be kind of problematic even getting that to fit on a sheet of paper well to where the scales are going to be readable for you guys. More likely you could get something that's maybe like 3/4 of a pi. That might be reasonable. But something with that big of a, that's a big long wave that's harder to get on a sheet of paper to where it's readable for you guys. Just from a teacher standpoint, that would be difficult to format a problem that would make that realistic. Now, if it was on like worksheet 2 where I gave you the stuff in words, there I could have something like that. Because I tell you exactly what the coordinates are of things and you have to figure out everything else from that information. And there, that's reasonable. I could give you something that's like 3.75 of a period. And then you need to figure out what the actual period is or the b from that. That would be realistic, but from a graph, I don't know that I could get something that was readable. Others? Worksheet 2, number 5. Okay. So this one here. Okay. The amplitude is square root 6, so immediately I know that the a value is either square root 6 or negative square root 6. And we're told the period is 7 pi, and the period is equal to 2 pi times the absolute value of b. So when I divide both sides by 2 pi, I can see immediately that b is either 7 over 2 or negative 7 over 2. Okay with that? Okay. And then we're told that our midpoint is 418, right? Since I'm given a midpoint, which trig function would I prefer to use, sine or cosine? You can use either, but one of them definitely makes life easier than the other. Ben? Yeah, I would use sine here. If you're given midpoints or midline points, sine usually makes life much easier. So for the parent function for sine, we have a midline point at 0, 0. And our transform function for sine, we have a midline point at 418. So immediately I can say that h is 4 and k is 18. Now, we still need to figure out whether our a's and b's should be positive or negative. Our b, we're always going to choose to be positive. And here, do we know what's happening before the midline point or after the midline point? What kind of extrema we're running into? No. So does it matter whether a should be positive or negative here? No. Either answer would satisfy the constraints of this problem, so it doesn't matter. We don't have enough information to tell if a needs to be one or the other, so it could be either. So here it didn't matter. So just for the sake of having one less negative sign rolling around in here, I would just pick the positive one. But if you wrote the negative one, it's not wrong. Josh, did that feel okay? Yeah, you're welcome. So Megan, here was a problem where it didn't matter what the sign was for A, either answer was correct, as opposed to the other one where we had a lot more information, where A had to be, in the case of using 0, 0, it had to be negative. Does that make, you can see the difference between the two problem types? Okay. It's a good question, because it's one of the things that's the least obvious that's going on there. But these are good questions, guys. Last chance before we move on to something else. Okay. Yeah, Delaney. On that same sheet? Sure. So, same thing. So we know that immediately. And this, same thing. You okay there? Okay. So, because we're given a minimum, should I use sine or cosine? Yep. So in the parent function for cosine, we use the point 0, 1, which is a maximum. And we're going to the transform point 5, negative 6, which is a minimum. So because we're going max to min, that tells me that the a needs to be negative. Okay. The x-coordinate tells us our h. And now to find our y-coordinate, we know ay plus k should equal our transformed y. So we have negative 3, which is our a, times 1, which is our y-coordinate, plus k needs to give us negative 6. So when I add 3 to both sides, we get k is also negative 3. Is that okay? So we have negative 3 cosine of 2 pi over 5 times x minus 5 minus 3. Oh, yeah, let's use, well, no, we should, the way we found the h, we need to pick b to be positive. Well, I guess for a cosine function, it doesn't really matter. But in general, you should just pick b to be positive. Unless you have a good reason as to why you're making b negative, just pick it to be positive. Ben? Found the k? Okay. So whenever we're transforming a parent function, we're using this, right? So I know that this y-coordinate, we did this 2 to get that y-coordinate. So I wrote ay plus k is equal to y, where This is the y from the parent function. This is the y from the transform function. So I just filled in my value for a and y from the parent and y from the transformed and solved for k. That would be a time where you have to use it. You could use it other places, but more often than not, we can get our k easier from easier things. I mean, you could have even gotten it, just reasoned it out that the minimum value and the amplitude is 3. So if you thought about it like from a graph, yeah. So one amplitude should be at the midline. So you could think about it that way also. There's no reason you couldn't think about it graphically and come up with the same thing. So you don't ever really have to use that. There's usually another way to kind of reason that out. But I like it because it connects back to the graphing stuff that we had just been doing. So it felt like a natural connection, and it reinforces this idea, which I think is an important one. Yeah, you're welcome. Do you feel okay with? Okay. What do we think? We ready to move forward here a little bit? I'll take your silence as confirmation. Yeah, sure. Oh, boogers. Look at what I forgot to do. I forgot to copy and paste this into the note sheet that we were supposed to be working on. Mr. Kulik, you're so stupid. One moment while I try to fix that real quick. Okay. That's pretty close. Get rid of that stuff. They do the same thing here on worksheet 3? Probably. Of course you did, because you're so dumb. You ever just like make mistakes and get so frustrated at yourself? Happens to me like all the time. Oh. Oh, boogers. I thought I had it. Okay. Okay. Time to talk about the tangent function. Get ready for information dump. So the parent function is y equals tan of x, not surprising. The domain is x equals pi over 2 times k. where k is a member of the integers. Oops. And k is odd. We'll talk about why that is here in a second. The range is all real numbers. The symmetry is odd. That means it's symmetric with respect to the origin. We have an infinite discontinuity, i.e. a vertical asymptote, at x equals pi over 2 times k, where k is an integer and an even number. The midline is y equals 0. The period, this is the thing that most students make a mistake on, is pi, not 2 pi. So make note of that. It's very easy to get going and forget that the period for tangent is pi and not 2 pi. Okay, so let's kind of explain some of these things. To do that, I'm going to use the unit circle. So recall that tangent of theta is equal to y over x, right? Everybody's okay with that? Okay. So tangent of 0 is going to equal 0 over 1, or 0. Tangent of 45, or pi over 4, is going to equal root 2 over 2 over root 2 over 2, which is 1. Tangent of pi over 2 is going to equal 1 over 0, which is undefined. Everybody's okay still so far? Okay. Tangent of 3 pi over 4 is going to equal root 2 over 2 over negative root 2 over 2, which is negative 1. Tangent of pi is going to equal 0 over negative 1, which is just 0. Tangent of 5 pi over 4 is going to be negative root 2 over 2 over negative root 2 over 2, which is just 1. Tangent of 3 pi over 2 is equal to negative 1 over 0, which is undefined again. Everybody okay with that? And then tangent of 7 pi over 4 is equal to negative root 2 over 2 over positive root 2 over 2, which equals negative 1. And then tangent of 2 pi is equal to 0 over 1, or 0. So if we look at this, what's going on here is this is my period, right? Notice that if I go one more section down, it's still the exact same thing. Or if I loop one more section down, it's still like the exact same thing, right? Everybody sees that the period is just pi units. Is that okay? Furthermore, notice that at pi over 2 we have a asymptote, and at 3 pi over 2 we have an asymptote. Oh, shoot. That should be not equals 2, so this has to be odd. My apologies, that's a big oopsie. And we can see that if that pattern holds, then every time we have like an odd number pi over 2, we're going to get another asymptote because of the periodic behavior, right? So the asymptotes are not part of our domain. Hence, we have our domain is everything except for that vertical asymptote. Everybody's okay with that idea? Okay. So if we tried to graph this section now, so I'm going to take this section, red, and graph it. So I have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and then, oops, that's not very symmetric, 3 pi over 2 again. So I have a vertical asymptote at pi over 2 and also at 3 pi over 2. Everybody's okay there? At 3 pi over 4, I have negative 1. At pi, we have 0. And at 5 pi over 4, I have positive 1. So following my asymptote, my graph kind of looks like that. So it looks like that is what I'm trying to draw. Yes, Elizabeth. Of course. Is everybody okay with that? Yeah. Usually, though, Delaney, what we do is we draw this period for the parent function. And those are going to be the key points that I list, but like one period is as good as another. But that's the idea. So let's do that over here now. So typically when we list the key points, we start with negative pi over 2. And go to positive pi over 2. The reason that we do that is so that we can include that key point 0, 0. Because we've seen that when we write the equations, that's a nice point to have access to, because it makes finding the h's and k's really easy. Does that make sense, Delaney? Yes. And it's still like the same picture, right? I mean, regarding the parent function, yes, but we'll transform it to when we graph things. But yeah, that's what we like to use. So let's do an example here where we graph one. Sound good to you guys? So I would start, just like we did before, by identifying our values for A, B, H, and K. The value for A is -2. The value for B is +2. Very good. For H, 0, and for K, 3. So our transformation map is this, same as it always is. And then we'll write down our key points. And perform that transformation. And if something is undefined, it doesn't matter what you do to it, it still stays undefined, right? Is everybody okay with that reasoning? So now that we've found our points, it's just a matter of kind of plotting and then filling up the space provided, right? So I usually like to start by drawing in both my asymptotes. And then I have negative pi over 2 and 5, 0, 3, and pi over 2, 1. And try to put a little bit of curve in your graph like I try to do there. Everybody's okay with what I did? Megan? No, if there's a translation left or right, the asymptotes will change location, right? So if the h is not 0, the asymptotes will move also. Or in the case of this, even we had a b value, they changed locations, right? They got further apart. Delaney? Undefined is asymptote. So at pi, we had the asymptote. And at negative pi, we had the asymptote. So then we should just fill up the other space provided there, right? So I'll just kind of repeat the pattern. So I go 5, and then 3, and then 1. And then the same idea here, except we're going to start down here at 1, and then go up to 3, and then up to 5. Delaney? I'm sorry, you kind of trailed off at the end. I couldn't hear you. Why aren't they connected? So that I filled up the space that was provided. So all I did was worry about putting those 3 points in. So that one is that point. That one is that point. The same spacing and everything, the same heights, just like we did before, right? Yeah. Just like when we drew the sine and cosine graphs, we drew one period and then we just filled up the rest of the space, kind of repeating the pattern, right? Does that sound familiar? Okay. So that's all I'm trying to do there, is just fill up the rest of that space. That's usually the instructions on the test or the quiz or whatever. If I ask you to graph something, is to, find the key points for one period and then just fill the rest of the space on the graph by repeating that pattern. Does that feel okay? Pretty doable? What's the period in this case? Well, it's pi times b. So our b in this case was 2. So 2 pi. Right, the thing to remember here is that for tangent, period is 2, or it's just pi times b, not 2 pi times b. So be careful on that one. Feel okay with that, though? What if we asked you to go from a graph back to an equation for tangent? Can we do that? I hope so. Let me pull up an example here. Shoot. I gotta go somewhere else to get my example. looking for. Oh, excuse me. You get a case of the sleepies ever? I sure do. Okay. Oh my goodness, look at how little that is. That won't do it all. This one had better resolution to it. Okay. Oops. Yes, Ben.
So in the point where it starts to change direction, at this point,
Yeah, so this spot right here is kind of the equivalent of our midline point. So that can tell us our K value. Good. And then this distance is like our amplitude. Is everybody okay there? Oops. Oh, come on now. I'm gonna do that. That probably makes it a little bit easier to figure out what I'm pointing at. Okay. Everybody so far so good? How are we going to figure out the period? Well, I would just go asymptote to asymptote. So that's going to be pi over 2 in this case, right? If I go from negative a quarter to positive a quarter is a half. Everybody agree with that? So I know that pi over 2 is equal to pi times b. So definitely negative a half or positive a half. So far, so good. Feels very similar to what we've done, right? Nothing too tricky so far. The last thing is to figure out what the h is. So I'm going to use this point. So my parent function for tangent has 0, 0 on the midline. Now remember, for my parent function, we start, the graph points down. Then we have our midline point and the graph points up. Our transform function goes to 0, negative 1. It also points down, goes to a midline point, and then points up. What does this information tell me? That a needs to be positive, just like it does for sine, right? This is basically the same comparison that we make when we look at the sine graphs, is we look at whether it goes maximum, midline, minimum, or if it goes minimum, maximum, or minimum, midline, maximum. It's the same idea, except we're looking at whether the graph is pointing up, midline, down, or down, midline, up. Yes. Yeah. So what I'm looking at is the graph starts pointing down. Oops, we're talking about the transformation. And then we have our midline point, and then the graph points up, right? And I'm going to compare that to our parent. Whoa, boy. Which does the same thing. Points down, midline point, points up. Okay with that, Dan? And because those are identical orientations, it tells me that no reflection has occurred, so the A value needs to be positive. Is that okay? So I would do the same. I can do the same thing. I can do bx from the parent plus k, plus h equals x from the transformed function. So I have b times 0 plus h has to equal 0, or just h is 0. In general here, when we're doing these transformations, if we're going from a 0 to anything, the h is just whatever that other x coordinate is. Delaney. So this is the xp from the parent, and this is the xt from the transformation. Because I know that's how I get my transform point, right? Is I take my parent function, I do that, times it by b, and then add h to it, gives me my new x. But they were the same x, right? They're both. It started at 0 and it ended at 0. The only way that happens is if you didn't shift anything left or right. You know what I mean? Yes. Of course. You're welcome. You want to do another one of these? Sure. Sure. I think I have another one in here. Oh, good, I do. Shoot. Itty bitty little thing. There we go. Okay. So what should our K be? That's where I usually would like to start. 2. Very good. Everybody okay with that? Okay. What's our value for A going to be? 3 or negative 3, but you're right. We're just not ready to, I wasn't ready to say that yet. That's okay. And not your fault. So that distance there from the next point back to your midline is the same, is going to give you the value for A. Is everybody all right with that? Notice that we're going from 5 to 2, so that's how we got the 3. Right? Okay. Next up, let's find our value for B. So this is 1 period, so that is pi units, which then easily we can see that B is -1 or +1. Are we okay there? Okay. Now let's find our value for H as well as the sign for our A. So our parent function starts at 0, 0. We go down, midline, up, in our transform function, we're going to the point negative pi over 2 comma 2, and we start going up midline down. So because these guys are opposites, it tells us that the a is negative. Ben noticed that earlier. Doesn't matter when you notice that, but I figured I'd wait to point it out here when I have the most evidence for why. And then to figure out my value for h, well, that's just going to be negative pi over 2. So because I'm starting with 0 and I go to pi or negative pi over 2, that immediately tells me the value for h. Using that same work that I wrote down before, Dan, but you don't really need to write that work down. You can just state what it is. Since it's a 0, the h is always just going to be whatever the other coordinate is. And then we always pick b to be positive, or b to be the positive one, because it just goofs stuff up if it doesn't. How do you feel on that? Sound okay? Cool. So I'd like you guys to do 15 to 26 from the problems. And then if you guys can take out your tablets and open up the content library, it's homework quiz time. Yay, homework quiz. I can, but I have to put the homework quiz where it needs to be real quick. So if you open up your content library and you look at the bottom, you should see something that says Homework Quiz 3. If you can't see that, try resyncing and it should pop in there. I just synced mine. Once you're able to find that, go ahead and save it into your own notebook. Do that. There's 2 problems there to do. And then you'll publish your OneNote file as a PDF and then upload it into PowerSchool. I'm going to make the assignment right now. Okay? And you have until the end of the hour to do that. There's just 2 questions. They should look relatively familiar. If you've been working on the homework, which I trust that everybody really has. You guys are such good students. Right here. Okay. I'll just let them roll in now. My synchronous students, I'm going to stop the screen share for you guys, so don't get freaked out. But you're just going to see my lovely mug here since we're done doing stuff that requires you looking at my computer screen. You know what I mean? And keep in mind on the homework quiz, because this is a OneNote file, if you need to make more space for yourself to do your work, just like put your cursor in there and press enter, and it'll make, it'll move the questions to make more space for you. You know what I mean? Some of us write bigger than others, or show more work than others, and need to draw little pictures or do calculations or whatever you need to do is okay. Oh my goodness. Are you guys tired yet? It's a good thing there's only 3 days this week, I don't think I could have made it 5. Sure.
So would that be 3 pi or 3 over?
3 over. You're welcome. Ben, in those situations, if you're ever not sure, you can just type it in your calculator and see, and press the decimal button and kind of see which one matches up. You know what I mean? Not that I'm not happy to answer that question, but you'll take some standardized tests at points. And it's nice to have little hacks for ooh, did I do that right? That's a nice little hack anyways to check those sorts of things. Oh, goodness gracious.